Okay, so let's add some conclusion kind of things to the Dipti Singh et al. Paper, which we have used as the main source for this series of podcasts. It's going to amount to a few hours, but it's just meant as an introduction or a primer on monsoon extremes and not a comprehensive course or anything. So the four main robust changes that have emerged from recent studies, as listed by the authors, is first, a long-term weakening of the large-scale monsoon circulation, decline in seasonal rainfall over the monsoon core region, and an increase in parts of western and peninsular India. So this is the map we saw from Roxy Matthew Cole's paper. For example, there is a horseshoe pattern over which the extending from northwest India to eastern India to southwest India, where the seasonal monsoon rainfall has decreased, but it comes with some increases on the northern part of the Western Ghats and parts of peninsular India, whereas Kerala to the south has seen some decreasing rainfall, and that has relations with the swing of the low latitude, low level jet, or the Somali jet or the Findlater jet, which brings in the moisture and so on. Okay, so that seems to be robust. The explanation for that, of course, was that the aerosol forcing over land has caused solar dimming, and the land didn't warm as fast as it should because of its low heat capacity compared to the ocean, which affected the meridional temperature gradient and reduced the seasonal rainfall. Now the big question is whether the monsoon is indeed recovering after decades of decline. This has to be looked. We have to watch out for it for the next few years to a decade or so. Secondly, changes in the frequency, intensity, and duration of large-scale, low-frequency extremes known as active and break spells over central India. Okay, these include an increase in dry spell frequency, increase in short duration wet spell frequency, and increase in wet spell intensity. So as we saw, these are derived from observations, but the projections are not along the same line in all models. So some models say the intensity of break periods will increase, the frequency will decrease, and so on and so forth. So one has to be careful about future projections in the context of what has happened during the observed warming in the last few decades. Thirdly, an increase in widespread extremely heavy precipitation events greater than 100 to 150 millimeters per day across central India, and increases in the intensity of intense, that is greater than 95th percentile precipitation events at finer scales across much of India except eastern central India. Okay, so widespread extremely heavy precipitation events have increased, and the increase in the intensity of intense precipitation events at finer scales. So this talks about spatial variability of extreme events. So there are two issues. One is the temporal changes in the intense or extremely heavy precipitation events versus the increase in their spatial variability. So this is the arguments made in Subimal Ghosh's papers. As we saw, there are differences in data sets used and so on and so forth, but dynamically speaking, if eastern central India is not seeing an increase in these finer scale precipitation changes, then why is it not, and how is that related to the temporal changes in extreme rainfall events? All these have to be dynamically consistent, so one cannot just diagnose observational evidences. One has to then take it further to see if the dynamics of those spatial variabilities and temporal variabilities can be explained, and whether models can provide an insight into these spatial heterogeneity of extremes and temporal trends in extremes. Finally, a reduction in duration of dry spells and intensification of wet spells over western and northwestern parts of India. So typically the low rain regions in the west-northwest of India are seeing reduction in the duration of dry spells, but intensification of the wet spells over those regions. So the consequences and strategies for dealing with those rainfalls in terms of water resource management and so on are critical to understand, especially in terms of what these historical changes mean for the future changes in those characteristics. Okay. We'll conclude this paper with this chart of summary of established and potential pathways for by which anthropogenic forcings can influence seasonal and subseasonal rainfall characteristics. Okay, so we are starting here with anthropogenic forcing as the main driver, because of which we are so keenly interested in extremes, seasonal rainfall changes and subseasonal extremes and so on. Of course, there are natural variabilities like the multi-decadal mode of monsoon, which probably would have dominated the focus if anthropogenic forcing wasn't there in a counterfactual world where changes were only natural. But right now the question also is whether anthropogenic forcing is really independent of the multi-decadal mode, or whether it is modulating the multi-decadal mode, or if the multi-decadal mode is going to disappear and we're just going to have trends over time because of anthropogenic forcings. Those are the bigger questions. Within that, the anthropogenic forcings include aerosol emissions, which affect clouds, microphysics and optical properties, and that's going to affect seasonal and subseasonal rainfall variability. Aerosol emissions also affect radiation and energy balances with direct effects, so these are the indirect effects, and those can be manifest through temperature gradient changes, tropospheric temperature changes leading to circulation and thermodynamic responses, which in turn can affect static stability, which relates to rainfall processes, including extremes, monsoon depressions, which is the monsoon rainfall characteristics over synoptic and low frequency time scales. So you can look at LPSs or low pressure systems and monsoon depressions in the synoptic time scale of 3 to 10 days and low frequencies of 10 to 100 days, which are both going to be affected, and intraseasonal oscillations, which are the monsoon intraseasonal oscillations, mesos, which are related to monsoon depressions as well in terms of creating favorable conditions for the genesis of monsoon depressions. All of those are going to feed into seasonal and subseasonal rainfall variability. So that's the dynamic and thermodynamic changes and timescale changes of active and break periods, as well as amplitude and propagation speed of monsoon intraseasonal oscillations. So those are going to be superposed on top of greenhouse gas emissions, which are going to also act through radiation balance and energy fluxes and propagate through the same pathways. Anthropogenic forcing also comes through land use and land cover change, which is also going to affect radiation and energy fluxes, which is not always getting as much attention as aerosol and greenhouse gas emissions. But they're also going to affect local moisture recycling, so soil moisture persistence and soil moisture abundance, and its impact on local energy flux, as well as re-evaporation and feedback to the active and break periods and seasonal mean rainfalls. These are some important processes which are going to affect seasonal, subseasonal rainfall variabilities, including the subseasonal and shorter period extremes. Okay, so including diurnal cycle. Okay, so that's kind of a quick run through. I'm going to add some other paper focusing on the so-called atmospheric rivers, which is a concept that has caught much attention these days, especially starting over western US, where there are processes which bring boatloads of moisture which have advection timescales, so they can be predicted, and they bring heavy rainfall and snowfall over parts of California and western coast in general. And considering the low-level jet and the moisture being trucked in by these winds, you expect that there is atmospheric river dynamics happening in the monsoon region as well. And there is a nice paper by Abhilash Sukumara Pillai and his group on a Kerala flood event, which was related to the atmospheric river phenomenon, and it's worth looking at because I'm sure this has much more of a role to play even at lower intensity extremes and not just the massive historic event that happened over Kerala. So I'll add that as a podcast and maybe conclude this primer on monsoon extremes. Okay, see you in the next podcast.